Listed below are altitudes, thousands of feet, and outside air temperatures, degrees Fahrenheit, recorded during a flight. Find the A, explained variation, B, the unexplained variation, and C, the indicated prediction interval. There is sufficient evidence to support a claim of a linear correlation, so it is reasonable to use the regression equation when making predictions. For the prediction interval, we want to use a 95% confidence level with the altitude of 6,327 feet or 6.327 thousand feet. Now, since the altitudes are in thousands of feet, we want to use this value 6.327 because that's what these values are here. So first thing we want to do is we're going to open this up into StatCrunch. So now that we open up this in StatCrunch, we're going to go to Stat and then select Regression and then go to Simple Linear. We want to make sure our X variable represents the altitude. The Y variable represents the temperature. I'm going to scroll down to the bottom here. Okay, and it says we want to create a 95% confidence level, so we want to make sure we select that. And then again, we're not putting 6,327. We want to put the value of 6.327 in here. So 6.327. And then we're going to go ahead and select Compute. Now we're going to take a look at the display. So here's our information. So here we have our regression equation, which is there. We have our correlation coefficient. We have R squared. And now we want to scroll down a little bit further. So this is the tab that we want to look at. So here, this SS below that is going to represent the explained variation. We want to round that to 2 decimal places. So this is going to be 10,936.61. So 10,936.61. And that tells us the explained variation. Now we want to find the unexplained variation. So if we go here to the unexplained variation, that's right below that. That represents the error. And again, we're rounding that to 5 decimal places now. So this is going to be 342.25189. So 342. Let's go back and take a look at that. 25189. 25189. Okay, now we want to be able to find the indicated prediction interval. So the indicated prediction interval is going to be the following. So let's go ahead and take a look at that. So down here, we put in our X value, which was in thousands feet. This is the prediction Y. This is what you plug into the equation to get this one. Now over here to your far right is the prediction interval. So we want to round that to 4 decimal places. So the first one is going to be 27.2842. So 27.2842 for the lower limit. And then the upper limit, rounded to 4 decimal places, is going to be 78.0561. So 78.0561. Let me confirm that again. 0561. Therefore, check our result. And there is the prediction interval. Now, if I wanted to find the total variation, I would add these two up. Now, when you add them up, they add them right here. So that would be the total variation.